Okay, so today we're going to cover all things functions, range, domain, all that good stuff. Alright, so there's actually not many prereqs for this, or if any, I suppose, so we'll get right into it. Okay? Start by defining what a relation is. And a relation, loosely speaking, can be defined as a set of ordered, we're going to call them pairs, but they don't actually have to be just two. They can be 3, 4, 5, whatever you want, okay? A set of ordered pairs, that's it, a set of ordered pairs, okay? And some examples of this can be like first name, comma, last name, right? That's a relation. You can have one person with a first and a last name. You can have the same first name with different last names. You could have the same last name with different first names, right? That's it. That's a relation. They link two or more ideas together in a certain order. Okay, for our purposes, it'll be 2. Yeah, that's it. Now, in particular, what we want is the domain. Set of all inputs that return a defined output for a relation. Okay? So for example, if we talk about students in our class, right? Let's say, I'll start with myself. My name is Amanda. My last name is Tran. Right? And let's name some other students. Joe, Schmo, and Abby Cadabry. Right? Okay. If we view this as a list of ordered pairs, right? Then our domain will be Amanda, Joe, and Abby, because these are inputs that have a valid output. These are inputs that have a valid something else attached to it. Not part of the domain would be Kylie. Not a valid input because there's no one in this class with the first name Kylie. Okay. So that is domain. Or codomain. It is the set of all possible outputs. This one's a little wonky. We cannot use names for this in the same way. And we'll get to why in a second, okay? Because you have a second concept called your range, which is the set of all achieved outputs. If you notice the difference, right? Codomain is a set of possible, range is the set of all achieved. Okay? Let's do an example. So for example, right, we know that y is equal to x squared, right? Let's say. We know that valid inputs are all real numbers. That's shorthand for all real numbers. Okay? You put in negative numbers. You put in positive numbers. You put in 0. You put in whatever you want. Okay. So that means this is your domain. Okay. Now your codomain is saying, hypothetically, what could we get? Hypothetically, this function takes real numbers to other real numbers. So these are possible outputs. I probably should have switched the order, oopsies. But here's the thing, right? Here's the thing we know about y equals x squared. You can't get negative numbers out of that. So your actual outputs are non-negative real numbers. That just means real, and what is the quality? Non-negative, so greater than or equal to 0, right? This is going to be called your range, okay? So domain, valid inputs, codomain, potential outputs, range, actual outputs, okay? We will not be using codomain very often, okay? At most I will ask, we will not be using codomain very often, okay? Not necessary for this class. But I do want you guys to have the definition. I will quiz you on the definition, okay? What you will absolutely need to know how to kind of calculate, look at, work with are domain and range, okay? Okay, so this is going to be our first grade scope problem, okay? And this will be due after the exam, of course. This is for the exam 2 portion. Okay, let's do an example. This will be due on grade scope. This will be your first grade scope question for post-exam, okay? It's number 7. We will be on page 57, okay? So write the relation as a set of ordered pairs, okay? So if we look at the left-hand side, right, we see the northeast and the right, which is the region, and the right-hand side as number living in poverty. Ooh, yeah, except those are pretty bad numbers, okay? So, and it's probably outdated, so it's probably worth it. Okay, so let's work this out. Your ordered pairs will be, and I'm going to shorten it because I don't feel like writing all that, okay? It'll be northeast, comma, oh, and you want it as a set. Northeast, comma, 54.1, comma, Midwest, comma, 65.6. Again, order pairs need to be in parentheses, okay? Comma, South, 110.7, comma, West, comma, 70.7. Okay? For part B, they want you to talk about the range and domain. Let's go back to the definition. What is a domain? It's all the possible inputs. So your domain is going to be northeast, well, that's a set, Midwest, South, and West. Your range is going to be 54.1, 65.6, 110.7, and 70.7. Okay, it doesn't have to be in this order because lists are because sets are unordered groups of items. Okay. Cool. Okay. Now for yes, you do have to submit this. Okay. For your purposes, for independent work, I want number 8. For practice purposes, I want numbers 8, 12, 14, 16, and 26. Okay, so this is your first part. Okay, now let's talk about relations, different kinds, all that good stuff, okay? So a relation can have some of the following properties, okay? It can be injective, which means 1 to 1. We'll get to what that means in a bit. And it can be surjective. Or onto. Okay? Talk about what that means. When we talk about injectivity or one-to-oneness, right, it should feel quite straightforward once I, yak about it a little bit. Okay, so injections, they're gonna make a lot of sense, okay? It means, or one-to-one is gonna make a lot of sense. It means every output comes from a unique input, okay? So that means if you plug, let's say you have a function f of x, right? And you plug in a, right? If you do it again and you say, oh, I plug in b for f of b, right? If f of a is equal to f of b, then that only works if a is equal to b for injections. I'm going to cut that out. So big picture of what that means is, nope, let's do something different. For example, right? One way to say this is if the outputs are the same, then the inputs are too. Okay. Let's do an example. Y is equal to 3x. Because let's do a grade scope question. Okay. Is y equals x squared injective? If yes, explain why. If no, give an example. Okay. And then my next question is y equal root x injective? If yes, explain why. If no, give an example. The next thing we'll cover is surjective. Okay? And surjective means, or onto, another way to say it, is all possible outputs are achieved outputs. So another way to say that is your codomain is equal to your range, right? Or another way to say it is your codomain is filled by your domain. Okay? So for example, for our purposes, right, your codomain cannot be, at most your codomain will be the real numbers. That's the biggest set of numbers we'll work with, okay? So for example, y is equal to 3x. Is this surjective? Yes, it is, because you can get all real numbers as an output. If you want negative numbers, there's some negative x you can put in. If you want positive numbers, there's a positive x you can put in. If you want y equals 0, then you plug in x equals 0. Okay? So for grade scope purposes, let's have you guys look at y is equal to x squared. Is this surjective? Okay? Okay. So the last property we'll talk about is bijective, okay? Or a one-to-one correspondence. One-to-one correspondence. All this means is your relation is both injective and surjective. Okay? Of course, it comes with some very fun properties. If your function is injective, every output comes from a unique input, and it is surjective, every possible output is achieved, then your domain and codomain are the same size, and that's very interesting. Not a U problem right now, but it is interesting. Okay, because that means your your relation is also invertible. Okay, that means you'll learn this in pre-calc. It means that you can always recover what the input was if you know what the output was. Okay, you can invert the function. It's very cool stuff. Another way to say it is you can actually swap the domain and range, turn it sideways, and it still behaves nicely. Okay. So big picture, relations, they can be injective. Every output comes from a unique input. If two things give the same output and your function is your relation is injective, the inputs were the same to begin with. If your relation is surjective or onto, then it means all positive outputs are actually achieved. A relation is surjective, it covers all the real numbers, okay, for our purposes. Bijective means it is injective and surjective. It's invertible. It's got a one-to-one correspondence. You keep hearing me use the word function. What's a function? We will define that right now. A function is a relation in which every input returns one unique output. Okay? Different than injective. Injective says, let's draw a picture. So for injective, right, every output comes from a unique input. Okay? That means that, let's say this is your domain, and this is your range, right? And you say, oh, this is A, B, C, and this is 1, 2. This is okay. This is not. Okay? If B maps to, that's what we say, maps to 2, and C also maps to 2, then B must equal C, or the function is not injective. Okay? For a function, here we go. For a function, domain, range, A, B, C, 1, 2. For a function, you can do this. This is okay. All right? What you can't do, what you cannot do, is this. Not a function. Okay? Function, not a function. Okay? And of course, right, functions can also be injective and surjective as well, and so on and so forth. Okay? Some of you guys may also have heard of the vertical line test. Okay? This is the vertical line test. It's saying every input gets a unique output, right? And of course that means that for injective, it's the horizontal line test. Okay. Yeah. Okay, for grade school purposes, hey, I know this seems like a lot. Hear me out. For grade school purposes, I want you guys to do these problems. Okay, ready? Okay. You're gonna do number 6. It's just, is this the function? Okay, is this function? You're gonna do number 10. Same idea. We're going to do number 12, which is determine whether the function, whether this is it a function, okay? Using the vertical line test. Again, easy, right? I want you guys to do 16 to 20, which is still, or number 16 is still, is this a function? Number 17 to 20 is, look at it. Interpret the meaning of f of 2 is equal to 5. What does that mean? Write the ordered pair. Again, super straightforward. Number 22 to 28, it's just plug and chug. This is f of x, this is g of x, this is h of x, this is k of x. What's k of 2? How would you solve for that? I want you guys to solve it all the way down, and the only reason why, without a calculator, and the reason why I gently insist this is because I want to make sure you guys know how exponents work, and I want to make sure you guys know how absolute value works, okay? Because if you leave it as like absolute value of -3, on paper that would be fine, but I want to make sure you guys know the absolute value of -3 is +3, okay? I want 22 to 28. Yep, just got that. I want 32 to 35. Again, same idea. I want number 42. I want number 49 to make sure you guys know how to work with fractions. I want, where are we? So I want number 62. Wait, let's back it up. And it's not bad, number 62 is not bad. 62, they give you a graph, they want you to find g of -1. So you plug in -1, what's your output? Given a graph. I want you guys to do number 80, which is just find the domain of this function. What are all valid inputs? Okay? I want you to do number 86, which is, again, what are all the valid inputs? And then I want you guys to do number 94, which is find the domain. What are all the valid inputs? Okay? And the reason why I insist you guys do these problems is because I want to make sure you guys know how range domain work. And in particular, I want you guys to know how radical functions work as well. What's a valid input, what's not, why is it not valid, so on and so forth. Okay? And that's it for range, domain, I know this is on the longer end. I will trim it down as best as I can. And thank you for your attention. Have a good one, guys.